This is question number 18 in chapter 5. It says a transport plane takes off from a level landing field with two gliders in tow, one behind the other. The mass of each glider is 700 kilograms, and the total resistance, air drag plus friction with the runway on each may be assumed constant and equal to 2,500 newtons. The tension in the tow rope between the transport plane and the first glider is not to exceed 1,200 newtons. Question A, the speed of 400 meters per second is required for takeoff. What minimum length of runway is needed? And question B, what is the tension in the tow rope between the two gliders while they are accelerating for the takeoff? So here we need to solve for acceleration. So we'll set up our force equals mass times acceleration. So our total forces cannot exceed 12,000. And then it's going to be subtract. Let's see, so you got the 2,500 newtons from two gliders. That's 50 or yeah, 5,000 or 5,000 equals our mass. So the mass of both gliders, so 700 times 2. So you have 1,400 times acceleration. Now we just need to solve for acceleration. You divide by 1,400, comes out to, let me get my calculator out. Equals 5. So 5 meters per second. Now we can use that to find how much runway we need. The equation we can use is velocity squared equals initial velocity squared, plus 2AR, because we can plug in all our numbers. So we have our acceleration. Let me back up here 1 second. That's right. So question A, it says you need a speed of 40 meters per second. So our final velocity would be 40, and then squared equals your initial velocity is 0, so that term just drops, plus 2 times our acceleration, which is 5, times r, or our position, or how much runway you need. So you just divide by 2 times 5. See, so 40 squared is actually going to be 1,500 divided by 10, which is 160 meters, I believe. So you're going to need 160 meters of runway for the planes to take off. Now we just need to plug this in to, let me find it in my notes. So now we can just plug it back into a force equals mass times acceleration equation. So between the two gliders, before we had 1,200, because we knew that that was our max, and we didn't want to exceed it. And now we're going to use T, and then minus 1 glider worth of resistance, which is 2,500 equals mass. See, the mass was 700 kilograms times 5. So if we add 2,500, that will give us our tension. $6,000. So our tension equals 6,000 newtons. And that is question 18.